Good day, everybody. Daniel here. Back with another episode. I've been away. No, I've not. I've been right here. I've not been right here, but I've been going to campus every day. So there was really no time for me to record any episodes. But today I got very motivated to actually come back and record something. But before I even get to that, I wanted to say that I will be recording episodes. I have an idea of what I want to record. I have a whole course that I want to teach and record lessons. So those videos will be coming, and when they do come, they're going to come thick and fast. So it's just going to be one after the other every day for a very long time. But for now, I'm still busy learning every day, and today the reason I came back early is because I wanted to actually record this episode. And so what happened today was that a student came up to me and wanted assistance. They wanted me to help them with their project or assignment, a school project assignment, whatever you want to call it. Very interesting. So basically what's asked of them is to create somewhat of a browser tracking history tracker, or browser history tracker, where the user who uses the program, which is a terminal application, can navigate backwards and forwards. So it's basically essentially this that you see over here, backwards and forwards. So this is the actual interface that they want you to program. So you need to be able to, the user needs to be able to add a URL like this draw that we're on right now. The user needs to be able to navigate backwards. So if they click this button, or if they press 2 in that regard, it goes backwards. If they press 3, it goes forward, or it navigates forward. And if they press 4, it exits the application or terminates the application. So that's basically it, really. So you are asked to use a stack. So if you think about it, a stack, you insert one element on top of the other, and then the only element that you can access is the element that is at the top of the stack. Just want to show you something real quick. std stack. Hopefully my internet works. Yes, it should work. So the only element that you can access is the one on top of the stack in std. You can't really traverse the stack. The only way to traverse the stack is if you keep popping elements out of the stack, and you can perhaps reach the desired element that you want to get to. My internet is a bit slow. It shouldn't be slow because everything should be working perfectly, but anyway, we'll disregard that. We don't need the internet. So I'll just show you the implementation of the stack std class when this actually loads. It's just something wrong going on today. Okay, so I just want to show you an implementation, or not an implementation, but the structure of a stack. The structure of the stack. This is the structure of a stack. So as you can see, elements are stacked on top of one another. The only way you can reach an element like this element, for instance, is if you actually go through all these ones that are above it. So you need to pop this one out, and then if you call top, so your stack.top, you will actually get your element that is now at the top of the stack. And that's basically it. So if you look at this stack implementation, you realize that there's going to be a problem. We can navigate backwards by just popping out elements from the stack, but how are we going to go forward if we're just using one stack, or we're just using a stack and no other data structure? Because these ones are popped, they're basically lost from memory. You can't really access their data or access them at all because they're gone. So the only way we can actually go about this is if we either use a different data structure like a vector or a DQ, or we actually use another stack, for instance. So if I were to create a second stack over here, right, so I'll just name this stack 2, right? So just name this stack 2. If I have these elements in this stack and I wanted to go backwards, like maybe reach this element over here or even this one, let's just keep it this one. What we can do is that we can pop off an element from the original stack and put it oh gosh, okay, let me just change the background of this, make it green. How do we change the background? Make it okay, make it that color. If we pop it out and we actually, why is this not showing? I'll just put it here. If we put it there, I really don't understand why this is not showing. Okay, there we go. If we put it here, we popped it off, and then we pop this one out again, and then now we can access our element in the stack. And then how do we go forward? Since we just went backwards, how do we go forward? If the user were to click on number 3, navigate forward, what would happen? So it's simple. We just pop this element from the stack 2, we'll put it all the way back into our main stack or the stack 1, and then all of a sudden we now have access to our element here, which is in our original stack, and we can navigate forward again and just take this one all the way back, put it over there. So that's basically how you actually deal with this problem. You need 2 stacks. You cannot use 1 stack. So you would have to, you would just basically have to create 2 stacks. So that's basically what the problem statement is, and we can actually get to coding. But before we can actually get to coding, I actually wanted to say that when you do add a URL, as these are URLs, well, you would just insert it into the stack. But whenever you do any operation, the program wants to know when, or your lecturer or your teacher, whoever wants your assignment, wants to know what's the element or which address are we currently at. So you would, after every operation, basically tell what the current URL is. So that's just to define the problem statement. So we're actually given something. We're actually given this validate URL. So you can't just insert a random URL. You need to insert this. You need to insert a valid URL, like a www.google.com type of URL. Obviously HTTPS, etc., etc., etc. valid URLs. But in this case, they just want us to insert a www.something.com URL. And this is the regex pattern that we're going to use. This is just the validate function. It's very simple. And then this initialize file. So we're given a file. So this is the file. Where is it? Browser history. This is the file that we're given, and this file contains URL. So basically the instructor wants us to use these values or this file and insert each and every single one of these elements inside of the stack. So these are our base URLs, and then from then on the user can add a URL, navigate or exit. So that's basically it. So I just wrote this code right here so that we don't have to re-implement this code again, and I'll explain it later. So without further ado, we can get started. I'm just going to increase the size of this so you guys can see. Just put it over here in the middle. I'm gonna minimize everything. So yeah, let's just get started real quick. Okay, this might be a long program, or it might be a little bit of a long video, so bear with me guys. I have my coffee here. I don't know how long it's gonna take me. I'm pretty sure I used up around 10 minutes explaining, but anyway, without further ado, let's start. So I have a plan on how I'm gonna actually do this. I'm thinking of actually writing down all the functions. I'm gonna use function-based methods. I'm gonna actually create this video using function-based solution, and then I'm also going to create another video where I use classes, because the code is 90% of the code is reusable. However, some students might prefer class-based solutions, some may prefer functional based solutions. So this is the functional way. I'm going to define all the functions here first, and I'm gonna start inserting all the code. So I'm gonna start with the skeletons. So before we actually do that, we include the IO stream. We don't use vector, the F stream to actually use this file, regex, and also the stack like that. So First I'm gonna actually, in the main function, I'm gonna try and not have as much code in the main function as possible. Everything will just be functions, so I'll just basically be calling maybe 1 or 2 functions. So but before that we need to actually initialize these 2 stacks. So I'm gonna say std stack. It's a stack of strings because URL is a string, right? std string, and then my stack, I'm just gonna name it this is a backward stack and a forward stack. My main stack will be the back stack, the backward stack, and I'm gonna, oh, why didn't that work? Okay, std stack again. Could have copied the code. It's a string, forward stack, like that. So we've basically instantiated our stacks. So now what do? We're gonna just basically create the skeleton functions, right? So I'm gonna basically want to call one main function or main application function that's basically gonna run. Maybe we can call it app. That's just basically gonna run, and it's just, you know, this is what's gonna run. It's gonna simulate the entire application. Let's just define it here. It's a void, returns void app. It's gonna take in the backward stack and the forward stack. std stack, std string, yeah, and then it's gonna, so basically all these functions over here are gonna reference these stacks over here that I created, instead of copying the stack over and over again whenever I'm calling a function. I'm gonna reference it like this. So I'm gonna say backward stack, and then similarly I'm gonna copy this code since it's a stack for the forward stack. Maybe it's a bit confusing. I'll just put this over here. Maybe I should just increase this entire, yeah. So if you don't know why I'm looking slightly to the left, just know that I'm using a white screen. Okay, so we have this app over here. So we have our arguments or our parameters backward stack and forward stack, and which is the code will run over here. So now let's create a function that or our regex function. Let's just copy the code. Oops, let's just, can I do that? Oh no, okay, like that. Alright, so that's my validate function, and my file initializer, I'm gonna copy that as well. I'm gonna place it here. I'll explain what the file initializer does at the end, but for now let's just leave it there. I'm just gonna do this just so that we know that those are the base functions that we got from the very beginning. And now what we're gonna do is, so we have the app that's gonna simulate the entire application. We need a function to add the URL, right? So we're gonna say it's a void add URL. This is the function, and it's gonna take in, what is it gonna take? It's gonna take in a URL, the backward stack and the forward stack, right? So, or is it gonna take the URL? But we'll solve that problem when we get to it. But for now, let's just make it that it takes in the URL. std string URL, like that. Let's just do that. Just, yeah, and then that's what it does. And then we're also gonna have a function to add what is it called? Oh no, navigate backwards. So it's a void. All these functions are voids, by the way. Navigate backward, and it's also gonna take in backward stack and a forward stack. What did I do? And similarly, the navigate forward is going to take in a backward stack and a forward stack. So very simple, right? So I think these are the only functions that we need, and we can just start implementing the code. So our application, let's just start with the very basics. So we're just going to start with this menu here. We're just going to create a toString a toString method, really. That's just going to return all this menu, and then we're just going to make the menu work in this function over here. But before that, let's just make sure that the file initializer works. So it's just going to call the file initializer, and we're going to pass in the backward stack, which is our main stack. So there's let's just file initializer. I want to pass in our backward stack. So this should, when we run this function, this should work. The browser history.txt is inside the same directory as the test.cpp over here. So let's just try and run that. Let's just say g+g test.cpp, and obviously if you don't use the terminal, then you have your own ways on how you run your own program. Then running it and nothing happens because we're not actually doing anything. So it works. Okay, so we initialize, and then now we're going to call that actual app, which is this function over here, and we're going to pass in what? The backward stack and the forward stack. And how we do that is that we're going to say backward stack and then forward stack, like that. So now let's just actually do something over here. So let's just start by printing print the menu items. So let's do that. So how do we do that? std cout, we're gonna say menu, right? And we're gonna say backslash, or is that a forward slash? And then we're gonna give it one, which is add URL, and then we're gonna do it again, next line, and then we're gonna say, which is 2, navigate backwards, navigate backward, and then we're gonna say 3, navigate forward, and then we're gonna say next line, and then 4, exit std end line, like that. So if we run that application, we should be able to receive something. So there's no next line between the navigate backwards and the next line. So let's just do that real quick. Let's just do that. There we go. So now we have our menu, add URL, navigate backwards, navigate forward, exit. So we have that created, which is good. So I think we're gonna basically, because this app needs to run all the time until you actually press exit. So we're gonna create an endless loop, so an infinite loop that basically keeps asking you the same thing until you actually exit the program. So I'm just gonna say while while true, print out this information, right? While true, and then take in a cin, std cin, that basically asks what the user wants to do. So it takes in a number, so option. So this option is a number that I need to declare. So before I do that, let me just get rid of this commented out information. So let's actually declare the number. So it's an integer option. What's going on? Okay. So integer option. So now we're seeing in the option, and then the user can select 1, 2, 3, 4, 4. So now I'm gonna say what's it called? I'm gonna say okay. So we're gonna create a switch statement to see what the user actually has chosen to do. Switch. So the expression would be our option, and then the case would be our numbers. So if the user selected 1, then what we want to do is we want to say, okay, call the add URL function. Add URL. Alright. And then inside the add URL, we're gonna pass in the URL string that the user wants. So, but we don't actually want to do that here, because the add URL, in the add URL, we want the user in this function itself, we want the user to actually we want this add URL to also have an infinite loop where it keeps asking the user, hey, this is not a valid URL, please select a valid URL, this is not a valid URL, until the user actually types in the valid URL, and then we can insert it into the stack. So until the user actually inserts a valid URL inside the stack, we're not gonna accept it. So I think we're not gonna do it here. We're not gonna do all that looping over in here. We're in this function app. We're actually gonna do it inside the add URL function itself. So we're gonna get rid of this URL, and we'll take the URL inside that function itself instead of passing it through as an argument. So in here, we're just going to pass in the backward stack and the forward stack. And if you're wondering where we're actually getting these from, we got them from here, where we initially declared them from the main function, and we passing them by reference over here. And now we get them by reference over here, as you can see by these ampersand signs, and we're also passing the same stacks or the same objects in memory to these functions over here. So this application is basically talking about the same two stacks. So we're passing these two, and then now we go over to the next case, case 2. So if the user types in 2, we're gonna call in, what is it, navigate backward. Navigate backward, that's the function, and we're gonna make use of these two stacks again, and we're gonna break. I'll just do that in a second. Case 3, now we're gonna say, oopsie daisy, navigate forward. Right, and then case 4, well, forgot the break. We're gonna call in exit. So case 4, we're actually calling return. That will exit out of the program, and then this will be break. And yeah, just like that, we're gonna call in, we're gonna pass in these two parameters over to these two functions. Semicolon on the break, and that should take away my error. So as you can see here, we're basically in a forever loop until we actually return in case 4. So if the user types in exit or types the number 4, it exits. Other than that, it calls all the relevant functions, and this is how we actually create our app endless loop, and we can test that. But we can't really test it right now because these functions have nothing. Well, actually we can. I'm lying to myself. So let's compile that code. Should compile, and then we're gonna run it. So there we go. Okay, before I actually do anything, let me just okay, well, actually everything is fine. So let me just insert a value here. I'm just gonna say exit. If I click on for exit, it exits the application. If I run it again and I say navigate backward, well, it can't do anything because we didn't code anything. Similarly number 3, similarly number 1, but if we press 4, it exits because we already return here. So that works perfectly fine, so we can continue. What should we do? I think we should start with the add URL. So let me start with the navigate backwards first before I go to the add URL, and you'll see why I want to do that in a second. So navigate backwards, basically I have a stack, and then we're just going to check what's behind underneath it by popping out all the elements in the main stack, or in this case in the backward stack. How do we even begin? I think we start by doing error checking. If the size of the stack is 1, that means there's only one element in the backward stack, and in that case we can't actually go backwards because that's the last element in the stack. So I'm going to say if backward stack dot size, right, is equals to 1, and you still want me to navigate backwards, we're going to return an error. Std sir, no backward like that. I'm just gonna use this like that. So we return an error because that's the last element in the actual stack. Other than that, if they are more than if there's more than one element in the stack, then we can actually navigate backwards. So what we're going to do is that we're going to pop the backward stack element and take it over to the forward stack, and then we're going to return, well, not return because it's a void function, but we're going to basically be pointing at the top element in the backward stack. So how do we actually do that? So we can push the element to the forward stack like this: forward stack dot push, and we're going to push in the backward stack's top element. Backward stack dot top first, right? That's the top element, and then we're going to remove the top element from the backward stack. Backward stack dot pop like that. That's pop like so. So top and pop, and that's basically it. So that should be great. That should be absolutely amazing. So this should work. There's no reason why this shouldn't work. And similarly, this code actually works the same for navigating forward. So if I can just copy this code and I can put it over here, and I'll explain why this also works for the navigating forward in a second. So, but let me just explain the logic. When navigating forward, right? When navigating forward, let's just say we have an element. Okay, let's just say we don't have an element. It's like this. We want to navigate forward. We're all the way over here. First, an error case. If we try and go forward and there's no element in here, then we are at the end of the stack. There's no element in the forward stack, so we need to return some form of an error. So we're going to say if forward stack dot size is equals to 0, right? Or actually, if I say if forward stack dot empty, right, if it's empty, then no forward element in the stack, that's an error. However, if there is an element in the stack, for instance, let's just say there's an element over here. Let's just say there are 2 elements over here, right? We want to go forward from this element. We want to go forward. Then what we do is that we want to pop we're going to actually take this element and place it in here, or copy it in here, and then we're going to remove or delete this element. So we're just basically going to do something like this, and that's the logic. So we're going to say our backward stack, we're going to push in from our backward stack, we're going to push in the element that is inside the forward stack. So backward stack, we're going to push in the element that's inside our forward stack, right? Or we're going to copy it, at least that's the top of the second stack, right? Our forward stack, and then we're going to remove it. So forward stack dot pop, and then we delete it. So that's why these two codes are similar, or these two functions are very similar. It's just one is the reverse of the other. And then we're done with that. Forward stack, navigate backwards. So but actually, before we actually do anything, we want to actually return, not return, but actually print out what the current element in this, or what the current URL is. And you must remember that the top URL will be the URL that is at the top of the backward stack. So I'll just print that out, cout, current URL is, let's just do something funny. Let me do this. What am I doing? Okay. Whoa, wait. Yeah, will be okay, what I'm trying to do is not working, but anyway, will be the URL will be backward stack dot top, like that. I prefer this actually, like that. Yeah, there we go. So that's our current URL. And we go to the next line. So that's it. So, oh gosh, what did I do? All right, I'm gonna print this here as well. Backward. Yeah, there we go. Now, so we created the navigate backward, and we also created the navigate forward functions. So now what we still need to do is add the URL. So adding the URL, before we add a URL, when we add a URL to our stack, so let's just say this is a random URL that the user wants to insert into the stack. Before it goes into the stack, it first needs to go through the function, validate if it is a URL or not. So we first need to check it against that. But before that, okay, let's just do that before I actually go into more details. I think it's just better if I do that. So what we're gonna do is that we're gonna run a forever loop, or a loop that is gonna keep on asking if it's gonna keep on asking the user to insert a valid URL. So we're gonna say while actually I can't really think about this properly. Let's just actually write the code. So we're gonna say if the valid URL, pass in the actual URL, but before we pass in the valid URL, we need to grab the URL from the user. We're gonna ask the user for a URL. So std sin, right, URL, but what is the URL? URL is a string, std string URL, like that, right? Instantiated URL. So we actually grab the URL from the user, store it as a string inside this variable here, and now we're gonna pass in the URL to the function. If this URL is a valid URL against this function, if it's true, if it returns true, then we can actually insert it into the backward stack, dot push, like that, URL. But before we actually push it into the stack, we actually need to do something first. What if we're in a situation where we have maybe 1, 2 elements in the forward stack, and we have 1 element in the back stack, and we have an element here that we want to insert into our back stack, right? Because this is where it has to live. We first actually need to insert this element back into here, take this element back into here, and then insert this element at the top of the stack. At least that's how I think these things work, right? Because if I go to google.com, right, oh man, I don't have internet, but if I go to google.com and after that I maybe remove this and I say, hey, forex.com or something like that, then what should happen is that if I press on back, it should take me back to google.com. So that's why I think we're supposed to actually take the elements from the stack 2 and put it back into the original stack. So let's implement that real quick. So before we actually push to the backward stack, let's start by running a loop for, we're gonna loop through each and every single element inside the second stack, and then we're gonna push it all the way back into the main stack. So we're gonna say for integer I is equals to 0, I is smaller than, I could have used iterators by the way, is smaller than forward stack dot size of the stack. We're gonna increment like that. So we're gonna say alright, we're gonna say backward stack dot push, right, the forward stack dot top, and then we're gonna pop it off, forward stack dot pop. We're gonna pop off the elements inside the forward stack, and we're gonna do that until we get to the size of the forward stack, so until there's no elements left inside the forward stack. And then after that, once we're done with that operation, then we can insert these elements inside like that, backward stack to push in the URL, and that's it. So that should insert, well, that little operation that we're doing here with the multiple elements here, we sorted that one out. So basically this will happen and the last element will be added to the top of the stack. So yeah, and then now what we need to do is actually make this keep looping. So this only works if this is a valid URL. If it's not a valid URL, we're gonna have to tell it, we're gonna have to rerun this entire code again. So how do I do that? Let me think. Well, I can make it kind of redundant, as in like I could just say if it's a valid URL then do this, if not, or I could just say else, then rerun this function again until you give me a proper URL. So I can do that. It's just a simple way to do things. Else, that means there's an error, std. I can just sir, and I could just say error invalid URL, please insert valid one. And what am I doing? Like that. Okay. And then I can just rerun this function again, add URL, and I'll pass in the backward stack and the forward stack. There we go. It'll be recursive until you actually give me the valid URL, and then in that case, if you do give me the valid URL, or I mean, I could do this, or I could just have said while valid URL is false, then keep running the same function, type of thing, until you actually give me the valid URL. However, this solution also works. If you do actually give me the valid URL, then we push it to the stack, and then we're gonna return the current URL because we've inserted it, and we're gonna say backward stack dot top. Or I could have also have said I could have just also have returned the URL because it's the URL, but this is more consistent with what we want to do. Yeah, I think we're done. I don't think there's anything else left to do. Let's just try and run this and see if we really are done, because you know how these things work. Let me just clear this. Let's compile that. Let's run it. Let's navigate backwards. Your current URL is source.gov.za. Backwards, current is UNISA. Backwards, no backward element in the stack. Current URL is unisa.co.za. Okay, so let's just add a URL then. www.google.com. Your current URL is google.com. Let's navigate backwards. 2. Current is SARS. Back, current is UNISA. Back, current is UNISA. Wait, where is Lions actually? Where is Lions? Where is Lions? Is Lions not inserted in the application? Because yeah, there's supposed to be Lions. Boom, boom, boom. So I think that's a little bug that I would have to deal with, and I could deal with it now, but I'm pretty sure this video is like 100 hours long. Actually, let me just keep going and say navigate forward. Let's just say navigate forward, SARS, navigate forward, Google, navigate forward, Lions. Oh, there we go. Oh, wait, is that the... Oh, there's a problem. I think the issue comes or stems from when we... I'm not sure if the bug actually stems from when we insert the elements inside the... well, it can be this because it stored the elements. It has to be when we... it has to be the last piece of code that we written, which is this dot size for I is smaller than forward stack dot size. Let me just do this real quick. The thing is, it might take a while for me to actually debug this code. Compiles, let me just see. Let's just add a URL first. Google.com. Oh, let's... okay, Google. Invalid. Please insert a valid one. www.google.com. Okay, inserted. Let's navigate forward. Forward, it's Google. Let's go backwards to Lions, to SARS, UNISA. Okay, so inserting an element at the beginning doesn't have any problems, but if you navigate backwards and insert an element, that's where the problem stems from. So it is this piece of code right here, this loop. So something is not being inserted. Or did I fix it? Actually, let me continue with this application. I've navigated all the way to the back. I'm at the last one, UNISA. Let me insert www.google.com. macbase.co.za. So we've inserted it. So let's go forward, navigate forward. You see what I mean? There's Google in front of it. Forward, there's Google in front of it. So when you insert an element inside the stack and you've navigated backwards before, then it will know. It doesn't go all the way to the end. It doesn't go all the way, all the way to the end of the stack. So when it's inserting elements, you want to insert this element into the stack. When it's taking back these elements, it disregards this one, and then it allows you to insert, and then it inserts this one. I am confused, but well, the application works. There's just a little bug inside of it, but I think maybe that's just the homework, or the writer leaves this problem as an exercise to the learner or to the student. Okay, so I'm sure you guys can fix it. I will definitely fix it, and I'll see you guys when I see you guys. Peace.